Okay, here we have a classic question, I would say, about elevators or lifts and acceleration of loads. Have a look and feel free to hit play when you're ready to see the answer. Okay. Um, so we're told the key to doing this question is really to think about what you're told in the question and the information there and how you can then sort of manipulate that. So the first thing we're told is that the load is accelerating vertically upwards. Now, in order to answer some of these statements, which I'm sure you've read, we need to remember a relationship between our force and acceleration, which is F equal ma. Okay, now what we've got here is a non-zero acceleration. So that means that the acceleration is greater than zero. We're saying upwards is positive, and therefore force is greater than zero. Now that F, force, is actually the net force on all of the objects here. And so therefore, the net force on the load cannot be zero. It can't be accelerating if it has a net force of zero, and so therefore A is ruled out. Now actually, you can rule out another one of our options here, which is B. Translational equilibrium says that force must be zero. Okay, so anything in translational equilibrium requires a zero force. Well, force is clearly not zero, and so therefore we've got non-equilibrium situation. So we're left with B and C. Okay, now these are quite wordy and sort of particularly like them that much, but I think we can go for them. It's worth our while thinking about where these forces come from. Let's look at B. Talks about the tension and the weight. So let's try that then. Well, we've just said that the force is greater than zero. Now the force is the difference between the tension and the weight, T take away W, and that is greater than zero. And so therefore, the tension must be greater than the weight. Now in B, it says they are equal but opposite. That's not true. They are certainly opposite. However, they are not equal, and therefore B is ruled out, and we're left with C. Now let's have a read of C. The normal reaction force on the load is equal but opposite to the force on the elevator from the load, i.e. the force from the load on the elevator is equal to the equal and opposite force of the elevator on the load. Now, this is a statement of Newton's third law. That makes a lot of sense. Whatever the load is doing to the elevator is doing to the load, but in the opposite direction. And therefore, that verifies our answer, which is C.